Hey, welcome folks to this IGCSE Form 4 topic coordinate geometry. And in this topic, we're going to touch on various interesting concepts like coordinates themselves, gradient, distance, and midpoint. Our main objectives are to read and plot Cartesian coordinates in 2 dimensions, draw shapes by joining points on the grid, also calculation of gradient or slope of the line, positive, negative, and zero gradients, including vertical lines, calculating length, coordinates of midpoints of line segments, also the origin with these coordinates 0 and 0, Cartesian plane, x and y axis, coordinates in form x and y, gradient, midpoint, distance. I think those are common terms that we'll encounter in the discussion. So the horizontal axis, we refer to it as the x-axis, vertical, that's the y-axis. Origin is with coordinates 0 and 0. And coordinates are generally written in the form, we start with the x value, then followed by y. Gradient of a straight line is defined as change in y over change in x. If the gradient is positive, the line slopes upwards. If it's negative, it slopes downwards. Or zero gradient is just a horizontal line or equation in terms of y. And the constant uh, x, when x is constant, this is a vertical line, and we don't have gradient for that because there's no change in x. Now, there's a common error take note of subtracting x coordinates and y coordinates in opposite orders. That might lead us to wrong solutions. Now, the distance formula, we have change in x squared over change in y squared. It's more like the absolute value between distance of 2 points. That will be drawn from the Pythagoras theorem. Midpoint, we find average of corresponding points on a line, similarly for the x and y. Then we are diving into the examples, right? The coordinates of a point A shown at 3 units right and 2 units up. Looks like both are positive. So it's going to be, if both values are positive, in coordinate form, it's going to be 3, 2. Moving to number 2, plot the points and join them. Okay, so I need a bit of a Cartesian plane there. And when I check my x, looks like it's running from -2 to 1. So I can simply sketch 1, 2, 3 there, and these are negative, and here I have 1, 2, and these are positive. When I move to y, it looks like it's running from 1 to 4. So it's 1, 2, 3, 4. So I can write here 1, 2, 3, 4. Let me change my color to try and plot. So -2 and 1, -2 and 1. I think it's this point, then 1 and 4, 1 and 4. So I'll be moving this way. I need another point. So when I join these two with a straight line, I mean, that's plotting and joining. Right. Next, find the gradient of a line that rises 6 units and moves 3 units to the right. So it's going to be change in y. So you denote it as m. So because it's rising, it means along the y, it's going 6, and along the x is 3, so the gradient is 2 in simplified form. Find the gradient of a line that falls 4 units when moving 2 to the right. So when it's falling, it means it's negative. So I'll be having m here -4 over 2. So this gives us a gradient of -2. Then moving to number 5, find the gradient of the line through those points. So I'm looking for m, and I know this is my y, and I'm interested in changing y. So it's 10 minus 2, it gives me 8 over changing x, 5 minus 1, that's 4. So my gradient is actually 2 again. Moving to example 6, find the gradient of the line joining. I think it's similar procedure. This is my y. So if I want change in y, 7 minus 1 gives me 6. Then over 4 minus 4, that's a 0. So it means this gradient is undefined. In other words, there is no change in x, so we don't have such gradient. It's actually a vertical line. Right, describe the gradient of the line y is equal to 3. Oh, the gradient m is equal to 0 because this is just a horizontal line, and we know horizontal lines have gradients 0. Then moving to number 8, find the distance between, well, distance formula, small letter d is equal to root of, well, we target corresponding x values and we find the difference. So it's 4 minus 1 squared, plus we do the same for the y, 6 minus 2 squared. And when I simplify, this is generally root of 3 squared plus 4 squared. So the distance is going to be 5 according to the Pythagoras. Find the midpoint of those given points. So if I want midpoint, which is normally denoted as capital letter M, is going to be, so I can say midpoint AB. So this will come from average of 2 and 6, as well as average of 4 and 8. And as I do so, this gives me 8. So the coordinate will be 4 there. And this gives me 12. That will be 6. So those are the coordinates of the midpoint of that particular line. So the midpoint is known here. So if the midpoint is known, we can start by saying 3, 5. They come from a certain point 1 plus the x value of the second over 2 plus 3 plus the y value of second point over 2. Then when I look at my equation, I think it tallies to, let's see, it tallies to these two connecting. So it's 2 times 3, that's 6, and 1 plus x. So the second point B will be having the x coordinate of 5. So that if we say 5 plus 1, 6 over 3, then the second one will be 2 times, that's 10. 10 minus 3, 7. So the other one will be 7. Those are the solutions for the first 10 problems. I hope you guys you find this interesting. We'll meet in the second part where we are refreshing on the same type of problems. Thank you.